It's not much of a question here, but hopefully it's obvious what to do. So have a pause and try in your own time if you like. Cos 2x. That's immediately reminding me of double angles, so I'm just going to go through some faff here with this. Cos 2x is cos squared x minus sine squared x. So that's option number one. Option number two would be to, do you know what? I'm going to dive straight to thinking about this cos squared x here. So maybe it's going to be helpful if I replace the sine squared x with the cos squared x, which means that then that's going to be 2 cos squared x minus 1. So that's option number two. I think it's fairly obvious that option number two looks the most promising. So let's roll with that. I'm then going to put this in a box, because I like to just box out my working. So then we've got this is equal to the integral of 2 cos squared x minus 1 divided by cos squared x. So good chance that you spotted as well as me that, oh look, I can split this into two fractions because there's only one thing on the bottom. So that would be the integral of 2 cos squared x over cos squared x minus 1 over cos squared x dx. Oh look, that simplifies to the integral of just 2 then minus sec squared x dx, and then that just becomes 2x because 2 integrates to that, and then sec squared just integrates to tan, so that would be minus tan x plus c, and that's the answer. You possibly spent a while deciding what to do with the cos 2x. Notice how quickly I twigged because I realised there was a cos squared theta on the bottom. Although I'm going to let you into a secret, which is that I'm a bit like playing chess. I managed to see ahead, and I realised that I was going to end up with 1 over cos squared x pretty rapidly from this. And I realised that was sec squared, and that would just integrate to tan. So if you happen to spot ahead like that, it can definitely make things much easier. If you don't, it just means you've got to slog away and try a few more things, because my initial thought when I saw this was, I wonder whether sine squared over cos squared, that'd be integrating tan squared. And I initially thought, oh, I wonder if that integrates really easily. But for whatever reason, my mind rapidly got drawn to, oh, I could replace it with 1 minus cos squared. Anyway, there's a bit of waffle about how I personally came to come up with that answer.